Hello to you and welcome to another awesome episode of Tenfold Live. My name is Sibusiso and this is another installment of over 100 episodes of maths and science that we have lined up for you this year. A big shout out to Liberty for making this possible. This show comes to you weekdays, Monday to Thursday from 5 p.m. until 6 p.m. So do make sure that you don't lose or miss out. You can of course get in touch with us via social media. For more details on this, just go to our Facebook page. In addition, go to our WhatsApp, send us your questions and comments, and you stand a chance to win awesome prizes such as a 19-inch TV, airtime, as well as data. Without any further waste of time, we're going to go to the math, but it is also important for us to mention that there is great content that is readily packaged for you. If you want to access this, just go to your favorite app store and download the Tenfold Education app. It will give you access to awesome content that will help you in preparation for your end of the year exams. We're now going to go to a question that was sent to us by Ayanda. Remember, this week we are focusing on factorizing polynomials using the factor and the remainder theorem. Ayanda sent us an awesome question. If you also want us to look at yours, keep the questions coming in on WhatsApp. Let's go and check out what Ayanda's question says.
Hello Tenfold, my name is Ayanda. I'm from the east side in Heidelberg. And I need help with my maths question that's been giving me a challenge. It says, for which values of p will x plus p minus 1 be a factor?
Right, thank you very much for that question, Ayanda. That is an awesome question. Okay, if you remember, based on what we've been doing up to so far, we are doing the factor theorem as well as the remainder theorem. And what we just simply said is for you to be able to claim that something is a factor, when you substitute an x value, the root of that particular factor, into your function, the remainder has to be 0. And that is what I'm going to use in order to answer Ayanda's question. So let's go and check out this question to see how it can help us. If you look at it, it does say, for which values of p will x plus p minus 1 be a factor of f of x equals x squared minus px minus 36. So the most important word here in this question is the word factor. For something to be a factor, based on what we said yesterday, you need to find an answer of 0 when you substitute the root of that particular given divisor. So I'm going to take what is given to us here, this x plus p minus 1, and I will equate it to 0. X plus p minus 1. If I equate this to 0 and make x to be equal to, if I make x the subject, it will say x equals to 1 minus p. So this x value, I'm going to sub it into the function. When you take the x value that you just found and you substitute into the function, for this to be a factor, the answer must be a 0. So let's go and see what will happen if I take my function of f of x, which was given to us as f of x equals x squared minus px minus 36. I'm now going to substitute for x the value 1 minus p. Let's see what will happen. If I find f of 1 minus p, this will be 1 minus p squared minus p into 1 minus p minus 36. So if I follow the question through, it says for which values of p will this thing be a factor? Well, for this to be a factor, when you substitute this 1 minus p, the answer has to be a 0. So I'm going to equate this f of 1 minus p to 0 and try to simplify to see what will happen here. So when I put that as 0, we are going to have 1 minus p squared minus p into 1 minus p minus 36, and then we try to solve for x in this equation. So if you look at it, it is a binomial squared. That's the first term we are looking at. So 0 is basically equal to, when you square binomial, it's going to be 1 minus 2p plus p squared. And then when you simplify here by multiplication, you are going to get negative p. Negative times negative is going to give us positive p squared minus 36. Right. Now, after you have done this, it is very important for you to notice that you now need to group the like terms, all the p squared together, the p's and the constants, put it in standard quadratic form and try to simplify and solve for p. So let's see what will happen when I do that. My common terms here are p squared and p squared. When I add those, I'm going to get 0 equals to 2 of those p squares. And when I look at the p's here, I've got actually minus 2p as well as minus 3. That will give me minus 2p and minus p will give us minus 3p. And I have 1 as a constant as well as minus 36 right there at the end. This will give us minus 35. Then you continue to solve this. Of course, when you are here, you've got options. You've got a couple of options that you can use. You can either use the quadratic formula if you don't know how to factorize. A lot of people use that. If it works for you, do it. But if you can be able to factorize it, just go and try to find the factors. So I'm gonna be quick and factorize this. Let's see what will happen from here. This is gonna say 0 equals to, I will have 2p, right, into 2p. Those are the factors of 2p squared. And now I'm looking for the factors of 35. That will help me to get the 3 that I have there in the middle. The factors of 35 can either be, let's see that, it can be 35 times 1, but I don't think that will give me the 3 that I have in the middle. The other factors can be 7 multiplied by 5, and I think those are the ones that will actually work for us in this case. Let's see what will happen. I have to put 5 here and put 7 there. The bigger product must be negative, so the product of 2 and 5, I'm going to need to have a minus here and a plus there. Let's see what will happen when we do this. Then clearly you guys can see that we're now going to say 2p plus 7 equals 0, or p minus 5 is equal to 0. Now if I continue further, this is going to say 2p equals to negative 7, and our p comes out as negative 7 over 2. Or if I simplify this one, it's just going to say to us p is equal to 5. So if you look at the question, it was asking us to find the value of p. It says, for which values of p will x plus p minus 1 be a factor of this function? So it turns out that when p is negative 7 over 2, or when p is equal to 5, it does indeed become a factor. Now we can actually prove this to you by maybe let's take one of these answers. If I take this p equals to 5, this p equals to 5, just to prove to you that indeed when p is 5, this thing that was given to us is going to be a factor. Let's see what will happen if I do that. The function that was given to us is x squared minus px minus 36. So I'm going to write that. Let's take this here. F of x is x squared minus px minus 36. And then the divisor was given to us as x plus p minus 1. This is the divisor that was given to us in the question, which is the one that I have right here, x plus p minus 1. So this is just to prove to you that indeed when x on p is 5, we are going to get a factor. Now, we found that p is 5. So if I try to sub p as 5 here, I'm going to have x plus 5 minus 1. This is going to say x plus 4. Remember, we have to equate it to 0 for us to actually substitute it into the function for it to leave whatever the remainder that is going to give, which must be a 0 if this thing has to really be a factor. So my p-value is 5, and then when I sub 5 here, I'm going to get an x value of negative 4 as a root. So I'm going to actually see what's going to happen when I try to put this into my given function. X squared minus, we did say that p is 5, so I'm going to write 5x here minus 36. So if I sub 4 in this function, the answer that I'm going to get here must be a 0. If it doesn't become a 0, then it means we have a problem. So f of negative 4 is equals to negative 4 squared minus 5 into negative 4 minus 36. So let's see what will happen if I use my calculator. Right, let's see, it turns out that we don't have a calculator at the moment, but then we can obviously try to figure this out without a calculator. If you go down, let's see what will happen. Negative 4 squared is just going to be positive 16. 5 times 4 is going to be positive 20 minus 36. 20 plus this gives us 36 minus 36. And indeed, we end up with a value of 0. This is just to prove that when p is 5, our function is going to be perfectly divisible by the given linear function, which is x plus p minus 1. Now, if you go back again and you try to test the answer, p equals negative 7/2, you will notice that it will also give you more or less exactly the same thing. So thank you very much for that question, Ayanda. It was a great question indeed. Remember, once you see the weight factor, you must know that when you substitute your x value into the function, the answer must always give you a 0. If it doesn't give you a 0 and it gives you a remainder, that means the linear function that was given to you is not a factor of the polynomial that was handed out to you. So thank you for that. We will come back with more questions. After this, Julian will come and take another question. Don't go anywhere. We'll be back after this.